Well, hello everybody. Today I'm going to show you how to use our image processing software that we've developed as part of an interprofessional project at the Illinois Institute of Technology that we're doing in partnership with the IBM Watson team. At the moment, this program is called FITSDocument. I don't know if it's going to remain with that name forever, but at the moment, tells us it's a document-based application for processing FITS images. So I have it in the dock, so I'll just click on it, and the first thing that happens is a file open box pops up. We're not going to open a file right now, so I'm just going to click cancel. The process is, if you don't have a dark file, the first thing you have to do is make a dark file to process all your image. So to do that, you go to the Dark Files menu and select Make Dark. Window pops up, and then you have to pick the files you want to assemble into your dark. I have mine on a Stellina drive in the Expert folder, and the images we're going to process here are of M1 that we're taking at about 11C. So I'm going to use the 11.7C dark files that I have. And I know these are BGGR, so we have to use the flip. And I'm going to select the 100 images and hit open. And then I click the Merge Dark Files button. And it will go through, load all of those files. And while it is doing that, it is trying to find pixels that aren't the same from image to image and handle that by getting rid of them and not including them in the sum of images. So it's going through that for all of the 100 images, and we get the spinning cursor of death right now because it's not threaded. The image pops up, and then we can hit save. And then, because we're using a save box, we can save it anywhere. I am going to go ahead and put this in the Documents folder in my Master Darks. And this is a Dark 11C fit, and I have a few of these. So Dark 11C temp. So I'm going to get rid of all these. So that's the process for making the dark file. Now we can open it, and that's in our master darks. I'm not going to use these files because I have a master dark at 11C for BGGR. So let me just open that, and we can look and see what this actually looks like. So when we open this, we have a histogram box down here. We have the image. There are a few tabs up here. And there's a goodness of fit parameter down here as well. General, for the goodness of fit, you want as low a number as possible. But for dark, there's no image, so we expect it to be a pretty high number. We can then hit the second button, and it's actually going to process the original image. It's already processed it as it loaded in, so it's just displaying it when I flip back and forth between the tabs here. Now here we can see the very bright pixels that go throughout the image from the camera in the Stellina. All of these hot pixels have to be addressed before you can get a very high quality image. So we have to take this file and correct all of our image files for these hot pixels. Then to do that, we go to Dark Files, Subtract Dark. The first thing we do is we select the dark file, and I'm going to take that master dark. Then we have to select the files that we're going to process. These are in my Pictures folder, and these are all in my 5.1741 capture. And I'm just going to take the first 15 files, so we're not here all night. We load them, and then we apply the dark to the files. Now if we come down here to the pictures folder, it's saving everything to the pictures folder. And it does that because of Apple security. Apple security really only gives us easy access to two locations, the pictures folder or the downloads folder, and we thought it would be easier just to put things in the pictures folder right now. So now we have 15 dark corrected images here. The next step in the process is to extract the color information from the grayscale images that we've now created. To do that, we go extract color. We have to select the files to process, and these are in my pictures folder that we just created, and they are 1 through 15. The color conversion is by far the slowest part of this entire process, so I'm not going to color correct all of these. I'm just going to do one image. And right now I know these are BGGR, so we select BGGR. This is actually contained in the FITS header file, the header of the FITS file that the Stellina creates. So in the future, we're going to read that out of the file and not make people suggest or select this. But right now, it has to be user selectable. And then we're going to hit color convert the image files, and this starts the color conversion process, and we get the spinning cursor of doom. Again, we will thread this code probably early next semester and greatly improve the speed of some of these things. But right now, we wanted to get it out in people's hands to test and see what they're seeing. The more images we get people to process for us, the more we can improve the software. So, depending on your processor, this can take anywhere from about 35 seconds to a few minutes to do the color correction. This is an M1 Mac. It takes about 40 seconds. So you can see we now have green dark corrected, red dark corrected, blue dark corrected, and luminance dark corrected. So the processing gives us 4 files in RGB and a luminance from each of the images. So I can close this now. The next step in the process is to align the images to take into account any motion. And so we have to go align images, and we're going to select color images. So the first step is to select the primary image, and I've already color converted some of these, so we're going to go to M1 color, and we have a full list of 15 of each of these. And I'm going to just pick one of the luminance corrected. I find that aligning to the luminance is usually the best thing to do. It tends to be a little bit of a brighter image. It's usually a good idea to not do what I just did and just pick an image without looking at it. You really want to look at the image that you're using as the master before doing this, but I hope this works. Then you select all the images to align, and that's all of them, all the ones, color, luminance, etc. Now, if you have folders in this file, it won't select the folder, but I usually look through this to see in case there are any stray FITS files that belong to something else, because you don't want to spend time trying to align something that doesn't belong in the past. Everything looks fine here, so I hit open. And then I go and hit align the images. So now it starts putting aligned images, align luminous, align green, align blue, align red, for each of the images that we're going to use in the final, to create the final RGB image. So fortunately, this process is not too slow, but again, we can speed this up by threading, so there's no reason to do this one image at a time. So by threading it, we can do multiple images at once. Alright, now we have all the aligned images, aligned blue dark, aligned green dark, and so we have all these files saved. And one of the reasons we do that is so in case you make a mistake, you don't have to restart from scratch. Once you're done processing, you can get rid of all of these images. But I like having them all just in case I do something stupid, for lack of better words. All right, once the images are aligned, we have to go back and manipulate them to sum them. So that's under Mathematics, Add Images, and we're going to select the files to combine, and so those were all in the Pictures window. So we have to go back to the Pictures window and select all the blue images, hit Open, and merge the selected files. This is again doing the processing step where it's going and looking to make sure everything is the same, nothing's varying image to image, getting rid of the pixels that are very different. So now we hit save, and we can call this m1 underscore blue dot fits, and we have to go through this for all the blue, the green. So we select the green and then merge the selected files. Then we save that image, and so m1 underscore green dot fits. Then the next ones will be the luminance. Merge the luminance files. And then finally the red. Merge those and save the red. All right. Now we could either open these 4 files using the file open or the load window, or we could click on them in the Finder and drag them over. And so we'll open up those 4 files. Close that open file window. And so now we have 4 files. I'm going to look at the luminance. Now, because there's actually a real image in here, we have a reasonable number, for goodness, of image quality, 2.97. We can look at the histogram of this image, and we can see it's all focused at the lower range because this is a fairly dark image. Now we can look at some of these tabs. If I hit this tab here, I can see an enhanced version of the image. One of the things I notice is that I can see a bright spot in the center and dark spots in the 4 corners, and that's vignetting of the camera. And so these really should be processed by a light frame to improve the quality of that. That's something we'll work on early next semester on both making a synthetic flat frame and actually measuring the flat frame using the Stellina itself. So if I come back here, I can also do find stars and hit find stars, and this pops up a new window that I have to populate. Select an image. I'm going to select this luminance and hit find the stars. And what that does is it populates this 3rd window with the stars that it used to align the image. So I can look at that and blink back and forth, and I see the stars that it used to do the image alignment and processing to move them all together. Now, it won't use any saturated stars in this, so any star that's saturated gets skipped. But we use this to do the fine alignment, and it does both shifting of the image and rotation of the image. A few other things we use we use some advanced image processing. These are Fourier transforms of the images. These are correlations of the images, and we use that to help us develop what this goodness of image quality parameter actually is. So now that I have this, I can combine color images by going to extract color, combine color images. I have to populate all the parameters, otherwise these say none. Then I select luminance, red, green, blue, and make the color image, and there I end up with a color image. You can save it as a PNG, and this will call M1 underscore RGB, and it's a PNG file. So this you can pull into your favorite image processing software. We can see this image is a little red. We still have a little bit of tweaking to do on the color alignment. If I come back to the Finder, I now have this M1 RGB. And myself, for final processing, I tend to use Pixelmator Pro on the Mac, and we should be able to align that. We can see the green is just a little bit out, and so that's one of the areas where we have to push the green a little bit. But you can do things like adjusting that in Pixelmator, move it a little bit darker. Anyway, that's how to use our software. And again, we have the dark corners that actually does affect our image processing routines a little bit, and that's something that we really need to address in our next batch, so we're going to have some sort of correction for that. So that is how we use our software. I appreciate the number of you who have volunteered to test this alpha version. I'm sure you'll find a bunch of bugs, and we greatly appreciate the time you're putting in to help us, because the more images that we process, the better we can make the software. So with that, thank you and good night.